Hi, I'm Michelle Young, representing National Programming Service, your digital solution, and welcome to the 4D TV Interactive Guide. This guide is a result of requests from our customers for an instructional video detailing the steps on installing, programming, and troubleshooting your Motorola 922 4D TV receiver. Tech tip. Remember to hit the pause button on your DVD remote if you need more time to view the information presented on your TV screen before proceeding to the next portion of this video. Before we begin to disconnect your old receiver, it is important to take a survey of your satellite dish to ensure it is in good working condition. In order to obtain optimal reception on all the digital channels available with your new receiver, you should have a satellite dish at least 7.5 feet in diameter that is in good condition. Dishes smaller than 7.5 feet can be used, but may not be capable of receiving some digital channels. The receiver will also need to be fine-tuned or peaked much more often than a larger dish. A 10-foot dish or greater is highly recommended. Your satellite dish should not have any missing panels, holes, or dents, and must not be warped in any way. The dish must be able to move smoothly and uniformly from W7 in the west to W3 in the east. The cables should be in good condition without splices. There should not be any obstructions in the line of sight such as trees, buildings, cell phone towers, etc., which can dampen your signal. Because the reception of digital TV signals requires analog signals, you should repair or replace any equipment that prevents you from obtaining excellent analog reception. Now that you've purchased your Motorola DSR 922 receiver, let's open the box and see what's inside. As part of your package, you will receive the following: a Motorola DSR 922 receiver, a DSR 922 user's guide, a programmable remote control, 2 AA batteries for your remote control, 1 UHF antenna so the remote can operate at greater distances, 1 coaxial cable for attaching to your television, 1 RCA connection to support the composite connection available on your receiver, 1 digital audio connection cable, 1 telephone cord which you will not need to use or connect, and 1 telephone splitter cable. While there are many cables available in the package, the average setup will only require 1 or 2 cables. If you need any additional cabling, they are all commonly available at most consumer electronic retailers. There are many types and brands of analog receivers in use today. Most of them will have all the wiring connected to one receiver box from the satellite dish outside. Some receivers will have 2 boxes, one to move the dish and the other to transmit the television signal. Before removing your current analog receiver, whenever possible, you should position your dish to Satellite Galaxy 1R, commonly known as G1, located at 133 degrees west. You will also want to verify you are receiving a clear picture on both odd and even numbered channels. In the event you cannot receive any channels on G1, you will want to fix the problem before you disconnect your old receiver. G1 is currently the satellite used to download the interactive programming guide as well as firmware updates. Before we begin talking about connecting your new Motorola DSR 922 receiver, we should spend a little time talking about your satellite wiring. Many common problems are related to these wires being improperly connected. This is why taking the time to label your wires will help to ensure a trouble-free installation. It is also important to have a general understanding of what each set of wires do, because it will help you diagnose any problems that can occur in the future. Many problems can be avoided simply by checking to make sure the wires are firmly connected to your receiver. The satellite cable that connects to your dish is broken down into 3 primary clusters of wires, each of which controls a different aspect of your satellite dish. These wire clusters are responsible for controlling your actuator, your polarizer, and your LNB. Let's take some time to talk about the actuator and what wires control it. The actuator is responsible for controlling the movement of your satellite dish. It allows your dish to move and point to the specific satellite you want to watch. The actuator, which is driven by a motor, appears as a piston-like device that contracts and extends as the dish moves east or west. There are also horizon mount actuators, where the satellite dish will rotate around two large cogs. The way the actuator connects to your satellite dish is controlled by a set of wires bundled together on your satellite cable. This bundle consists of 2 thicker wires and 3 or 4 smaller wires. The thicker wires have an electrical current running through them, so it is very important to unplug your receiver before unplugging these wires. The most common colors of these thicker wires are white and red, but other colors may be used. These 2 wires will be connected to your analog receiver, which will be labeled M1 and M2. It is recommended that you label which one connects to M1 and M2 because they will need to be connected to your DSR 922 receiver in the same manner. Tech tip. The reason why it may be a good idea to label these 2 wires is because they affect the way your dish moves. If these wires are properly connected, your dish will correctly move towards the west as your dish position number increases. Reversing the wires, however, will cause the satellite dish to actually move towards the east as the numbers increase. We'll talk about this more when we begin programming your receiver. The remaining wires should consist of 3 or 4 thinner wires, one of which may be unshielded. The unshielded wire is your physical ground, which may or may not be connected to your analog receiver. The other 2 or 3 wires of the actuator controls the pulse. Only 2 of these wires are actually used for installation into your DSR 922 receiver. You will want to mark which 2 wires are connected to your analog receiver because they will be needed when we wire your new unit. Tech tip. If you find that all 3 of the wires are connected to your analog receiver, you may need to go out to your satellite dish, remove the cover on the base of your actuator to see which 2 wires are connected, and note the color of the connected wires. If you are unable to do this, it will mean having to do a little trial and error to see which 2 wires control the pulse for the actuator. You will know if your pulse wires are not connected properly because the satellite dish will move and the dish position number will stay the same. You may also get an error that states physical limits have been reached. If you find this occurring, you'll want to move the satellite dish back to where you were getting a clear picture, unplug your receiver, and refasten the wires to their terminals. Plug your receiver back in and try moving the dish again. If that still does not solve the problem, you may have connected one of the unused wires, and you should try using the other thin wire in the actuator cluster. So, the important things to remember about the actuator are: 1. It controls the movement of your satellite dish. 2. It is controlled by a cluster of wires that will contain 2 thick and 3 or 4 thin wires. 1 wire may be unshielded. 3. It is recommended that you label all your actuator wires for an easy hookup. 4. If you find that your satellite is moving to the east while your dish position number increases, you will need to switch the M1 and M2 wires. 5. If you are getting a physical limit error or the dish physically moves without the dish position number changing, the pulse and ground connections need checking. Now that we've gone over the actuator and the wires that control it, let's spend a little time talking about the polarizer. The polarizer is a piece of metal that sits inside the center of your feed horn. Depending on the channel that you are watching, the polarizer will rotate approximately 90 degrees to pick up either horizontal or vertical signals transmitted from the satellite. These signals are represented by either odd or even analog channels on any given satellite. In other words, all even channels for a satellite may be transmitted on a horizontal signal, while the odd channels for that same satellite are transmitted on a vertical signal. The purpose of having signals that are both horizontal and vertical is to prevent channels from other satellites bleeding in and distorting the image. To ensure that there is no interference on any given channel, adjacent satellites are said to have a flipped polarity. Your channel guide will often mark the channel listings to display satellites having a flipped polarity. Tech tip. You can use this information to diagnose problems with your polarizer. If you find that you are only getting odd channels on one satellite and only even on the satellite with flipped polarity, it means that your polarizer is not moving at all. This problem can usually be fixed by checking the wiring on the back of your receiver. Commonly, movement of the receiver will jostle these wires so the connection is lost. Try removing the wires and plugging them back in to see if that resolves the problem. This problem can also be caused by leaves or other debris blocking the movement of the polarizer, but more often you'll find that the servo motor has gone out and will need to be replaced. The servo motor is a box-shaped device that's connected to the back of the feed horn and is responsible for the rotation of the polarizer. This motor will have 3 wires coming out of it and will be connected to the satellite cable. These 3 wires will be clustered together on your satellite cable. Typically, the wire colors are red, white, and black. The red wire will be a plus 5 volt, the white wire will be the skew, and the black wire will be the ground. You should confirm this by looking at the labels on your analog receiver and then label each wire. So, to summarize, 1. The polarizer is a device that allows the satellite dish to receive both horizontal and vertical signals. 2. The wiring for the polarizer to the receiver consists of a cluster of 3 wires, which are generally red, white, and black. 3. It is recommended that you label all your wires. 4. Not every satellite dish setup has a polarizer, and we will talk about that in the next section. Now we will talk about the last and perhaps the most important portion of your satellite wiring, attaching your LNB. The LNB, or low noise block down converter, amplifies the signal captured by the satellite dish and sends it down a cable to the receiver. The LNB, as well as the size of your dish, are the biggest factors in getting strong, clear pictures. There are multiple types of LNBs available. The programming that you will be able to watch with your Motorola DSR 922 receiver will depend largely on the type of LNB that you have attached to your satellite dish. For example, there are a series of satellites that broadcast channels on a Ku band frequency, so you will need to have a LNB that supports Ku band in order to watch them. The absolute best way to know which type of LNB is on your satellite dish is to ask your dish provider. Viewing your LNB will require you to remove the nose cone from your dish, which may not be possible. The LNB should be labeled if it is C-band or Ku band, and if it is a LNB, LNBF, or dual LNB type. We may also be able to figure out the type of LNB attached to your satellite dish by understanding the type of programming that's currently available and the way the wires are connected to the back of your receiver. The first thing to see is if the polarizer wires are connected to your analog receiver. If you have polarizer wires connected to your analog receiver, you have a standard LNB. If only